Okay, 4.2, day 1. In this video, you're going to see a ton of factoring. I've kind of warned you, and I've said to you, look, let's take care of this. Let's make sure if you have factoring issues, we need to get them taken care of because, holy crap, we're hitting the ground running. It's factoring from here and factoring and factoring and factoring and factoring. If you stink at factoring, you're going to struggle in this chapter from here on out. It's why I've been stressing it to you so much. So in this video, all factoring. You're going to see, you're going to write everything as a product of linear factors, and you're going to find all of the zeros in this problem. So linear factoring, here we go. Let's take a look. Linear factorization theorem. What it says, obviously pretty straightforward. Linear factorization theorem means that everything can be grouped as linear factors. So that means that linear factors, every single polynomial, which hopefully you understand these are polynomials, every single polynomial can be grouped as a linear factor, aka x to the first power. We can group every single one of them. So, I start you off pretty basic. Take a look. Letter A. Write that as a product of linear factors and find its zeros. Hopefully you're looking at this and you're saying, okay, simple. Multiply to get this, add to get that. What are the two numbers that multiply and add? Well, it's -9 and +1. If I find the zeros, what makes x minus 9 equal to 0? What makes x plus 1 equal to 0? Voila, there it is. Take a look. Linear factors, there they are. The zeros, there they are. Okay, so understanding how to factor, simple. Understand the linear factorization theorem. Okay, so we got that. We're good to go. Let's try some more. Get a little bit more difficult. Okay, second one. If I look at this, I'm automatically thinking to myself, I gotta be able to group these. There are 4 terms. The only way I can factor something with 4 terms is if I group them. So let's do that. Let's group them. What do we get? So if I group the first 2 and the second 2, what does the first group have in common? There it is. What does the second group have in common? There it is. Linear factorization theorem. I know when I factor by grouping, they better be the same. I've said that probably like 20 times now. How do I group them from here? I group the outsides, and then I tack on the insides. I know I'm not done yet because that guy right there is not linear. Okay, so that's got to be linear in order for me to keep going. It's not, so I know I can factor it. Hopefully, you're saying to yourself, all right, that's got to be difference of squares. Notice how I'm stressing difference. There's a minus sign in between there. You can only factor them when they're difference of squares. So 1 minus, 1 plus. Voila, there it is. Let's maybe clean that up just a little bit. When I have it more than once, I'm just going to square it. If I have it 3 times, then I'll cube it. So it looks like +2 and -2 are my zeros. Remember, I knew that I should get 3 of them total. The +2 is 1. The -2, because it's a double root, it counts twice. So there are the 3 of them. I'm going to do a little bit of foreshadowing as to what's coming up in a few minutes. Your book likes to use, instead of double root, they like to use multiplicity. So if I say to you, this has a multiplicity of 2, that means that, well, there are 2 zeros. If it were a multiplicity of 3, well, then there would be 3 zeros, right? Multiplicity of 4, then it's to the 4th power, there would be 4 zeros. So your book likes to use multiplicity. That's coming up in a little bit. Just figured I'd do a little foreshadowing right now because we're talking about it. All right, let's get a little more difficult. Letter C. I'm thinking, I don't know how to factor anything x to the 4th. So here's kind of what I'm thinking, and this is just going to take some practice on your part. Here's what I'm thinking. If I wrote it like that, I know I could find 2 numbers that multiply to get this. Those same 2 numbers have to add to get that. Well, I know I can do that. So I wonder if I can do that for this problem that I'm on. Well, instead of an x and an x, I think it'll be an x squared and x squared. So think, first, I got the x to the fourth. Outside 1x squared, inside negative 4x squared. If I combine them, voila, I get the negative 3x squared. And last I get negative 4, so holy crap, that actually worked. So if you're not sure, FOIL them. Do you get the answer that you're looking for, right? It's kind of where I'm going, it's kind of what I'm thinking about. So from here, that's not linear, so I know I'm not done. Well, in this first one, I know I have difference of squares because obviously that's a minus sign and I have difference of squares. The second one, though, I don't have a difference. It's a plus sign, so I know I don't have difference of squares. How the heck are we going to solve that? Well, let's take care of the easy one. I got the x minus 2x plus 2. Think about how I got that. What I did is I essentially took x squared minus 4 and set it equal to 0. So that gives me x squared equals 4, and then x is plus or minus 2, which led me to those factors there. Alright, so if I think about that, maybe what I'm going to do is take that x squared plus 1 and take it to the side and see if I can do anything from there. So if I solve for x squared, if I take the square root, I know that the square root of negative 1 is equivalent to I, so I get this plus or minus I here. Well, if I get this plus or minus I think now, in order to factor it, I'll write 1 minus and 1 plus. Okay, so there are my linear factors. And then if I find my zeros, it looks like, voila, I'm done. Hopefully, that didn't go way over your head. Obviously, we're going to get some more practice on those, but write down, let's write down questions, anything that you don't understand, anything that you kind of need help with. Remember, let's write those questions down, and hopefully it gets a little bit better. But I think we got one more. Let's try one more. Alright, so I told you a little bit earlier about the multiplicity. Here it is. Pretty simple. Take a look at letter D. Factor the function completely, then state the multiplicity of each zero. Let's think about it. Let's just factor that. Let's factor that, see how that goes. Very, very easy to factor. First one, 4 times 4 is 16. 4 plus 4 is 8. Second one, if we factor that, looks like negative 5, positive 4. Let's tack on that x minus 5. And then if I factor them, just clean it up a little bit. How many x plus 4s do you have? How many x minus 5s do you have? And then what are their zeros? Well, it would be negative 4 and positive 5. What would be their multiplicity? Well, negative 4 would be a multiplicity of 3. Positive 5 would be a multiplicity of 2. Your book likes to use that, so let's kind of get into that habit when you see things more than once. Let's write the multiplicity of them. And looks like that's it, so good job.